Hello, welcome. Today we are going to be looking at nitrogen and its compound. Please, if you like our videos, hit the subscribe button so that you can be able to get our videos whenever we drop them. If you like our videos, always like, share it, comment if you have any question to ask or suggestions. Now, let's go to nitrogen and its compound. Nitrogen is the most abundant element as it constitutes 78% of the Earth's atmosphere. It is also one of the most important substances on Earth. It is an essential element for life and growth, for it forms a part of every living cell. It is a non-metal and falls into group 5 on the periodic table because it has an atomic number of 7. And therefore an electronic configuration of 1s2, 2s2, 2p3. Nitrogen occurs combined in the form of sodium triosonitrate 5 salt, saltpeter, NaNO3. This is actually O, not Q. This is O. Calcium triosonitrate 5, as well as ammonium salt. Please, these formulas are not correct. I'll be giving the correct ones soon. This combined nitrogen is also found in organic matter such as proteins, urea, and vitamin B compounds. Now, the laboratory preparation of nitrogen. How do we prepare nitrogen in the lab? 1. From the atmosphere. The gas in the air are oxygen 21%, carbon dioxide 0.03%, and atmospheric nitrogen, which is 78%. Since nitrogen make up a large percentage of the air, this is large, not large, it can be obtained from air by the other constituents of air. Carbon dioxide is removed by passing it through potassium hydroxide. Oxygen is removed with a red hot copper. Nitrogen obtained through this method contains about 10% by volume of rare gases as impurity. So you still have some rare gases or noble gases as impurity when you use this method. This method is simply by removing the other two major components of the air, which is carbon dioxide and oxygen. You remove carbon dioxide using potassium hydroxide and remove oxygen using hot copper. So what is left is nitrogen and the rare gases. Now, using method 2, let's look at method 2 for preparation of nitrogen. This method 2 is by the composition of ammonium dioxonitrate 3. Ammonium dioxonitrate 3 is not stable in the lab. It is generated by the reaction of sodium dioxonitrate 3 on any ammonium salt. The presence of these gases does not really alter the chemical properties of nitrogen, but it makes it a little bit more dense than it will be if fully purified. Now let's look at nitrogen compounds like ammonia. Ammonia is the hydride of nitrogen. In nature, ammonia is produced when nitrogenous matter decays in the absence of air. So actually ammonia is a hydride of nitrogen and it is produced when nitrogenous matter decay in the absence of air. Now there are traces of ammonia gas in the atmosphere due to the death and decay of plants and animals. Ammonia, because of its great solubility in water, rapidly dissolves in rainwater and finds its way to the soil, where it may be converted into other compounds. Now let's look at another compound of ammonia, the ammonium salts, which can be produced by neutralizing ammonia solution with the appropriate acid using the titration method and crystallizing the resulting solution. So when you have ammonia solution with, say, hydrochloric acid, you can produce ammonium chloride. Now let's look at uses of ammonium salts. Ammonium tetraososulfate 6 is used as a fertilizer and in a more concentrated form as a weed killer. Ammonium triosonitrate 5 is used as a fertilizer, example nitro chalk, and for making explosives, example amator or ammonal. Laboratory preparation of ammonia. Ammonia is prepared in the lab by the heating of an ammonium compound such as ammonium chloride with a cheap base like slakline, which is calcium hydroxide. Now let's look at we're going to stop here. We'll continue later.